Welcome to the first edition of You Get to Learn Math at Home for at least a week. So we're going to review what we did on Wednesday before we got sent home. So, kicking right in, we have here our formula for an explicit arithmetic sequence. So explicit means to get right to the point. So explicit means if I asked you to find the 90th term of something, all I would have to do is perform this formula and voila, I would know the 90th term. This is the more powerful formula. We then are going to go back and review the recursive formula. And the recursive means if I were to try and find the 90th formula, I would have to know, the 90th spot, I would have to know the 89th spot. And if I didn't know the 89th spot, then I'd have to know the 88th spot. And if I didn't know the 88th spot, then I'd have to know the 8th. So this formula here is really long and tedious. However, that's the one you actually use the most in computer programming. But we don't need to go there. We just need to understand the difference between these. So I'm going to do a quick review of them. This is the formula that we use to find the first term, or if they ask a certain term, or maybe how many terms there are in the sequence. This over here, this is Gauss's baby. This is if we wanted to add up an arithmetic sequence. And that was where he took the first number of a sequence, added it to the last number of a sequence, realized that that sum was going to be repeated by how many times we pair numbers up. Sometimes, when we're doing the summation formula, we have to go over here and get some information to finish this formula. So let's look at some examples. Start off with number 1. For the sequence negative 27, negative 12, 3, and 18, etc., etc., the expression that defines the nth term where a sub 1 is 27 can be written as, oh my god, all right, well look. Are they asking me anywhere in this question to sum anything up? No. So for now, we are not going to use this formula. For now, we're using this formula right here. So we should have all the information we need. If I take that formula, come down here, let's start filling in the blanks. For the sequence, okay, find the nth term. The nth term. They're not asking me to find a specific term. They're not like asking me to find the 4th term or the 9th term, just any term. That's found a sub 1. Oh yeah, we know what a sub 1 is. It's negative 27. The difference. Well, I set you up with an arithmetic. In other words, you should realize that from negative 27 to negative 12, we added on 15. And then to get from negative 12 to positive 3, we added on 15. And then to get to 3 to 18, we added on 15. So that's my difference, 15. And I don't know what n is because they didn't tell me where to go. And that's it. This is an expression. And in fact, we made an equation out of it. So we could have cleaned this up. And I'm going to clean that up some more. Negative 27 and negative 15 can get combined. And that's your explicit formula. So what does that mean? Well, it means basically this. I just created a formula where I could find any term right away. So just to show you, we know that the fourth term is 18. Well, we could do this. We could put in the fourth term is found by taking negative 42 and adding on 15 times 4. Well, 15 times 4 is 60. And the fourth term indeed is negative 42 plus 60 is 18. There you have it. Okay, look at question 2. In an arithmetic sequence, the fourth term is 19 and the seventh term is 31. They want us to again determine the formula for the nth term. They didn't ask me to add anything up, so I'm using the explicit formula. And once again, to find any term, I start with the first term and I add on differences. In fact, I add on n minus 1 differences. Okay, so you start looking at this and you're like, well, wait a second. They didn't tell me what the first term is. They told me what the fourth term is. And they told me what the seventh term is. So right now, I don't know anything here. But we can figure it out. We can take a little sidestep. We can say this. We know the fourth term is 19. Fifth term, sixth term, and we know the seventh term is 31. So basically what happened here, we added on a difference here, we added on a difference here, we added on a difference here. Okay, let's just write a little equation. 19 plus 1, 2, 3 differences got me to the number 31. By doing some basic math, let's see, 31 minus 19 is 12. We know our difference is 4. Now we can just count backwards. A sub 3, A sub 1, A sub 2, A sub 1. And we can minus 4, minus 4, minus 4. Oh, there's our first term of 7. So now let's go back. I don't know what A sub n is, and I don't need to. That's what they're saying. Write a formula to find A sub n. I do know what my first term was. My first term was 7. And we found out our difference every single time was 4. And minus 1. Now you can leave it like that. You can clean it up if you want. And just to show that we are correct, we know the fourth term is 19. So that means if I stick a 4, every time I see an n, it will explicitly tell me what's in that fourth spot. 3 plus 16, and yes, indeed, it's 19. So once again, let's read what we're doing here. What is the formula for the nth term of this sequence? Well, they didn't ask me to sum anything up. So once again, I'm writing here. So let's bring this bad boy down and see what we got. Okay, for the nth term, I don't know what n is there, and I'm not going to know what n is there. It says the first term. Oh, I know what the first term is. The first term is 10. And do I know what the common difference is? Let's see, I added on 2, I added on 2, I added on 2. Oh, I added on 2. Once again, I could stop right there. To find any term of this sequence, I start with the first number and I add on 2 differences, which I will clean this up because I like to clean up my math. To find any term, 10 minus 2 is 8 plus 2. And now, be careful here, right? This is not the first term. This is just a quick way to find terms in the sequence. So this is a sub 1, a sub 2, a sub 3, a sub 4. So we know a sub 5, if we just did basic math, should be 18. So let's see if that's right. I'm going to put a 5 in for n. And 10 plus, hey, look at that. Our fifth term is indeed 18. All right, so let's see what this one says. Finally, it's saying, what is the sum? Awesome. I get to use this other equation. Finally, they're talking about sum. So let's see what they got us to do here. The first 19 terms, and here's the sequence. Okay, so to do the sum, we know that this means n is 19. So the sum of the first 19 terms is found by pairing off those 19 terms. And obviously you can't pair off 19, it's an odd number. So we take the first term and add it to the, well, I don't know what the 19th term is. Well, that's where you have to come back here and use this formula. So we're going to take a little sidetrack. So here we are off on our little sidetrack. Okay, so to find any term, I start with the first term and I add on differences n minus 1 time. Well, I need to know what the 19th term is. So I guess I'll start with the first term, which is 3. I'll add on, what's my difference? What am I adding every single time up here? 3 to 10, 7, 10 to 17, 7, 72. Oh, I'm adding on 7 every single time. And I want to do that 18 times. This is my first term plus 18 more differences, because that's how many differences are between the first term and the 19th term. So let's see, the 19th term is 3 plus 7 times 8 is 56, carries 126. So the 19th term is 129. So now I can come back here, and now I know that my 19th term is 129. So the sum of my first 19 terms is 3 plus 129 is 132. And I'm going to multiply that by 19 over 2. I'm going to do some work here first. You guys will obviously pull out a calculator, but I'll take 2 as a denominator and cancel it with 132, which is a numerator. And that goes in there. Let's see, that goes in there 66 times. And then what is 66 times 19? So therefore, the sum of my first 19 terms is 1,254. Okay, so let's take a few seconds to look at recursive. Recursive always has to have 2 steps to it. Recursive has to give you a starting point, and then to find the next term, you're going to go to the term before it and do something to it. I mean, that's all recursive is. So when they do recursive, there's 2 ways to signify your brain that, hey, this is recursive, and it's not explicit. And first off is, they say the word recursively. And second is, recursive always has to have 2 parts, starting point and what you're doing to the next term. So which recursively defined function? The first thing I'm going to do is I'm going to stop right there. Recursively means I have to have two sentences. Each choice down here has two sentences. Where I start, what I do to it. 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 Okay, so they all right now are an option of being recursive. Okay, has a first term equal to 10? That means the first term of my function must be the number 10. When I go through there, okay, this is an option, the first term is 10. This is not an option, the first term is 4. This is an option, the first term is 10. This is not an option, the first term is 4. Well, I've just narrowed this down to a 50-50 guess. Okay, so what do they want me to do to this first term? It has a common difference of 4. That means I'm adding on 4 every single time. That means to find the next term, I must go to the term before it and add on 4. All right, so if I started off with 10 as my first term, to get to my second term, the answer would be 14. To get to my third term, my answer would be go back, look at the one before it, 14, add 4 onto that, 18. To get to my fourth term, go back, look at the one before it, 18, add 4 onto that. So, which one is saying that? Obviously, choice 1. This is saying multiply by 4. Choice 1. All right, one last one. If the pattern continues below, which equations is a recursive formula that represents the number of squares in the sequence? Okay, recursive needs to have 2 lines. Where I start and what I do to it. Wait. No, you don't have 2 lines. Okay, these have 2 lines. Okay, where did I start? I started with 3. Oh, you started with 1. You're not it. Answer. And yes, notice what you did. Every single time you added on 2 to the one before it, right? So right here, basically, they're saying you have 1, 2, 3. Okay. And then this one you had 1, 2, 3, 4, 5. That's right, I added on 2 on. This is 1, 2, 3, 4, 5, 6, 7. That's right, 5 plus 2 is 7. All right, so you are going to have a